Welcome back to math class, and in today's class we'll be talking on distances along parallels of latitude. Distances along parallels of latitude. And in today's class we'll be solving two examples on distances along parallels of latitude. Now, in our previous class where we talked about great circle roots on longitude, we have our formula to be theta over 360 times 2 pi r. But in today, we having it to be theta over 360 times 2 pi r, where our r is r cos theta. We have it to be r cos theta. And where we'll be using this will be explained while continuing this class. And our first example today says, find the distance measured along the parallel of latitude between 2 points whose latitudes are both 56 degrees north and whose longitudes are respectively 23 degrees west and 17 degrees west. So we have the longitude 23 degrees east and 17 degrees west. 23 degrees east and 17 degrees west. And we have the latitude to be 56 degrees. We have the latitude to be 56 degrees. Now, we know that point A is at 56 degrees north and 23 degrees east, and point B is 56 degrees north and 17 degrees west. Now, C is on our polar axis and it is the center of the parallel of latitude 56 degrees north. What am I saying? We draw a circle. This point is at point C. We have this is point O. We have our lines. So with our lines here, we draw a great circle. So we have something like this, and we draw our lines of long latitude. We draw our lines of latitude. So here at point C, where we have it to be 56 degrees north. So here is 56 degrees north. To point B, we have it to be 23 degrees east. We have it to be 23 degrees east. So this is our east and this is our west. So 23 degrees east, we can have it like this, and 17 degrees east west, we can have it like this. So here is our B and here is our A. So this is 23 degrees east to the east, and this is 17 degrees to the west. So bringing it out, we have it to be something like this. Here we have, so here is 17 degrees and here is 23 degrees. So we already have it like that, and we know that our radius will be 56 degrees. We have our radius to be 56 degrees. How is that coming out? From this point here, we have it this point, and to the equator, we have it like this. So this part is our 56 degrees. So here we have it to be 17 plus 23, which is 40 degrees. So we have our theta over 360 times 2 pi r. So we have 40 over 360 times 2 pi r cos 56 degrees. Solving for that, we now have it to be 40 times 2 times 22/7 times 6,400 times cos 56/360. Or we can easily write it as, since you know that 2 pi r is 40,000, we can write it as 40/360 times 40,000 times cos 56 degrees. So solving this, we have it to be 0 and 0. We have it to be 4 here 1, 4 here is 9. So we have 40,000 times cos 56 from our table is 0.5592/9, and solving is using our calculator. We have it to be 2,490 kilometers. We have it to be 2,490 kilometers. Now, our second example for today says, find the parallel of latitude in the northern hemisphere along which a journey of 640 kilometers makes a change of 8 degrees in longitude. Find the parallel of latitude in the northern hemisphere along which a journey of 640 kilometers makes a change of 8 degrees in longitude. Now, we know that the required parallel of latitude should be 0 degrees north. And we know that we have our r to be r cos theta. So we have to find the parallel of latitude, which is theta. We have to find a parallel of latitude, which is theta. So we already been given 8 degrees change in longitude. So we have it to be 8/360 times 2 pi r. And we have here to be 640 kilometers. So we have it to be, we cross multiply, where we have 640 times 360 equals to 8 times 2 pi r cos theta. So we know that our 2 pi r is 40,000. So we have it to be 640 times 360 equals to 8 times 40,000 times cos theta. So we have our cos theta to be 640 times 360 over 8 times 40,000. 8 times 40,000. And solving this, we have our cos theta to be 0.72. Our cos theta is 0.72. Now, the inverse of 0.72, where we have our theta to now be arc cos 0.72, we have it to be 43.95 degrees, where we can approximate it to 44 degrees. So we have it to be 44 degrees north as the parallel of latitude. And this brings us to the end of our class today on distances along parallels of latitude. So I'll be seeing you in the next class. Thank you.